Another thing you used to do in elementary school with fractions is to multiply and divide them. The method for multiplying and dividing fractions also works with rational expressions. Remember that to multiply two fractions, you multiply numerators and multiply the denominators. To divide two fractions, you multiply by the multiplicative inverse or the reciprocal of the divisor. So for multiplication, you could just simply take 2 times 15, so that's 30, 9 times 4 is 36, and then simplify, and that equals 5 6, and that will work. However, when you get into very large numbers, it might be difficult to simplify at the end. So instead, we can simplify before we multiply by looking at the numerator of one fraction and the denominator of another fraction and try to find the greatest common factor of those numbers. For example, if I look at the 15 and the 9, what goes into 15 and 9? Well, a 3 does. Divide both of those by 3. 15 divided by 3 is 5. 9 divided by 3 is 3. So I'm canceling those numbers into smaller numbers by dividing them both by 3. And then the 2 and the 4. What goes into 2 and 4? A 2 does. 2 divided by 2 is 1. 4 divided by 2 is 2. Then we multiply the resulting numbers left over. 1 times 5 is 5. 3 times 2 is 6. So we get the same 5 6. For division, we have to multiply the first fraction times the reciprocal. In other words, it's the same as keep, change, flip, which is the rule that some of you may remember, keep, change, flip. So we keep the first fraction the same. We change the division to multiplication, and then we flip the second fraction to 35 over 6. And then we try to do the canceling out from there. So what goes into 5 and 35? A 5 does. 5 divided by 5 is 1. 35 divided by 5 is 7. What goes into 3 and 6? 3 does. 3 divided by 3 is 1. 6 divided by 3 is 2. And 1 times 7 is 7. 1 times 2 is 2, for a grand total of 7 halves. These same concepts can be used with rational expressions. We can divide the numerators and the denominators of different fractions by greatest common factors and then simplify before we actually multiply. So looking at part A, I do see some numbers I can simplify. I see 15 and 5. 5 goes into both of those. 15 divided by 5 is 3. 5 divided by 5 is 1. I see 6 and 8. 2 goes in both of those. 6 divided by 2 is 3. 8 divided by 2 is 4. And then I can also start dividing out the variables in the exponents. So there is a d in the denominator of the first fraction and a d squared in the denominator of the second fraction. So the d down here can cancel out with one of the d's up there. And I do believe that is it. I don't see any other thing that I can cancel out. If I do miss something that cancels out, then you will have to simplify at the end. However, if I don't miss anything that cancels out, then I should not have to simplify at the end. So that will be 3 times 3 times c times d. So that would be 9c squared d over, and then the denominator I have 1 times 4 times a, so that would be 4a. So on part B, we have a division problem, so I'm going to apply the keep, change, flip method of multiplying those or dividing those by changing to multiplication. So let me rewrite that as 18xy cubed over 7a squared b squared. Change the division to multiplication and then flip the next fraction. So 35a squared b over 12x squared y. And then what can I cancel out? Looking at the 18 and the 12, 6 goes into both of those. 18 divided by 6 is 3. 12 divided by 6 is 2. Looking at the 35 and the 7, 7 goes into both of those. 35 divided by 7 is 5. 7 divided by 7 is 1. I'm looking at the x's. This x in the numerator of the top fraction can be canceled out with one of the x's down here. The a squares can be canceled out entirely. The b in the top right can cancel out with one of the b's down here. And then the y in the bottom right can cancel out with one of the y's in y cubed, and that would leave me with y squared. So I believe that's everything, so it's time to multiply. So I'll have 3 times 5, which is 15, and the variables that are left over is just the y squared, over 1 times 2 is 2, and I'm left with a b and an x. So there's that answer. So now let's try to do this with polynomials. We're going to factor both of these polynomials first, and then, so let's try to do these with rational expressions. We're going to factor all the polynomials that we can, and then see which binomial pairs can cancel out. So part A, I can factor the numerator to x minus 8, x plus 2. And the denominator is x minus 8, and then another x minus 8. Times. Numerator is already completely factored. It's just an x minus 8. And then the denominator will be x plus 3 and x plus 2. So what can we cancel out? Well, we can cancel out the x plus 2's. This x minus 8 could cancel out with one of these x minus 8's. And even though I have an x minus 8 over an x minus 8 in the same rational expression, I can still cancel those out, because that means that the first rational expression wasn't even simplified to begin with. So I've got to have something to put on the top of the fraction, and that something is a 1 over the last remaining binomial in the bottom, which is x plus 3. And that's that answer. For part B, I'm going to keep change flip because it's division, so it's x squared minus 16 over 12y plus 36 times y squared minus 3y minus 18 over x squared minus 12x plus 32. And then start factoring. So for x squared minus 16, that's x plus 4, x minus 4. For 12x versus 12y plus 36, I can factor by distributive property out a 12, leaving me with y plus 3 times. The second rational expression's numerator could be y minus 6, y plus 3, and the denominator can be x minus 4, x minus 8. So what can I cancel out? Well, I've got y plus 3's. I've got an x minus 4 here and an x minus 4 here. And I believe that is it. So my final answer is going to be in the numerator, x plus 4, y minus 6 over 12, x minus 8. Finally, we have what's called a complex rational expression, or a complex fraction. A complex fraction is a rational expression with a numerator and or denominator that are also rational expressions. The following expressions are complex fractions. Basically, they are fractions within fractions. You really shouldn't leave fractions within fractions. You should try to simplify them, and one way to solve a complex fraction is to remember that fractions are really division problems. So these are just like the last example we did. These are division problems, so let's change them to division problems. So we have a plus b over 4 divided by a squared plus b squared over 4. So if I rewrite that as a division problem, that would be a plus b over 4 divided by a squared plus b squared over 4. And since it is a division problem, I can do keep, change, flip. So keep the first fraction the same and flip the second fraction. The 4's cancel. What about the a plus b with a squared plus b squared? Do those cancel? They do not. They do not cancel. A plus b does not cancel with a squared plus b squared because a squared plus b squared does not factor into a plus b, a plus b. That is not correct. Again, this is not correct. And I know it's not correct because if I multiply it out, I get a squared plus ab plus another ab plus b squared, which is not the same as just a squared plus b squared. So that does not factor any further. And since that part does not factor any further, then we have our final answer after we multiply, which is just going to be a plus b over a squared plus b squared. Finally, the last one, x minus 2 squared over 2 parentheses x squared minus 5x plus 4 divided by x squared minus 4 over 4x minus 10. So let's rewrite that. This will be x minus 2 squared over 2 times the quantity x squared minus 5x plus 4. And I'm going to go ahead and do the change flip portion of it. So I'm going to change it to multiplication, and then in the same step, I'm going to go ahead and flip over that bottom fraction. So it'll be 4x minus 10 over x squared minus 4. I need to do some factoring here. So I'll leave x minus 2 squared at the top. The denominator will factor into x minus 4, x minus 1, times, I can factor out a 4, just a 2. I can factor out a 2 and leave x minus 5. And in the denominator, I can factor out x squared minus 4 into x plus 2, x minus 2. And then what cancels out? Well, not a whole lot. This x minus 2 can cancel out, and I erased it again by accident, can cancel out with one of these x minus 2's. And these 2's can cancel out, and that is really it. So once I multiply it all together, I will have x minus 2, x minus 5 over x minus 4, x minus 1, x plus 2.